Hello student. Assalamu alaikum. In today's class, I am starting the topic of A-level physics. Uh, this is the topic of waves, and this is AS topic of waves. And we check there is given progressive and stationary waves. Okay. It's mean there are two types of waves. Number one, the progressive waves, and number two, the stationary wave. Now I'm telling you what is the wave. Uh, Mainly, there are many types of waves present in our surrounding, and basically these waves consisting the medium particles. If wave consisting the medium particle, these are the mechanical wave. Now I'm telling you the wave. When we disturb the medium, any medium, air medium, water medium, glass medium, any medium which is maybe solid, maybe liquid, or maybe gases. In these three form medium present. If we disturb a medium from one side or from any position, if we disturb the medium, now what happens? This disturbance travel from one position to another position. Now this traveling disturbance is called wave. When we disturb the medium and disturbance, we disturb the medium at any point or any position. From this position, there is a disturbance which is produced. This disturbance travel from one position to another. Now, this is called the wave. This disturbance is called wave. Just like, for example, you are throwing a stone, you are sitting at a corner of a river or any source of water. No, there is water. Okay, there is water inside these two boundaries, and you are sitting here. When you throw the stone in the water, what happens? No, if a stone drop here in water, what happens? No, this stone disturb the water medium. You disturb water here, you throw the stone drop here, and stone give the energy to water. There is a disturbance form. Now this disturbance travel as a form of, now this disturbance travel from here to in forward position, just like in circular form. Now this traveling disturbance from this position to uh, ahead, forward, now this traveling disturbance is called the wave. Okay, it's mean when we disturb the medium and medium by due to the disturbance of the medium, uh, there is a we disturb the medium and disturbance moving from that position to the other position. Now this movement of disturbance is known as wave. This movement of disturbance is known as wave. Okay. Now here we check in the notes there is given. Now there are two types of waves. Number one, the progressive wave. Number two, the stationary wave. Progressive wave mean the disturbance traveling, uh, moving from one position to another position. Okay, now this is the progressive. When the disturbance or the wave moving, waves moving from one position to another position, one position to another position, it is known as progressive wave. Now, these are known as the progressive. These waves are known as the progressive wave because these wave traveling, energy traveling as a form of wave. Basically, when waves are traveling, we say uh, energy traveling. Okay. What is fact in it? Waves traveling mean the movement or motion of the energy moving from one position to another position. No, the disturbance traveling when the waves are moving. Progressive waves are that type of waves which are moving from one position or transferring from one position to another. And stationary waves are that waves which are not moving, which are stopped, not moving. When disturbance is not moving, disturbance stay at its position, it is known as the waves which are formed here, the stationary waves. A progressive wave transfer energy without transferring material. And in progressive wave, energy, when energy is transferred, the medium material is not transferred. Now note it. Medium material mean medium particle, water particle, air particle, solid particles. These are not moving. Only the energy transfer and but the particles not moving from one position to. Every medium is made up of the particles. Medium material mean particles. Medium material mean particles. Particles are not moving. Medium or field oscillating. Waters are made of water particles moving up and down. And medium particles moving up and down, vibrating. Medium particles vibrating. But energy transferring. Particles are not transferring, but energy transferring because when particle disturb, these particles disturb the other particles, and due to the disturbance, when particle disturbing uh, first particle disturbing the second disturbing the third, now this disturbance travels, and this is a form of energy. Particles not moving from their position, it's mean medium is not moving, medium particles not moving, medium material not moving, only the energy transfer which is not a medium material, which is energy is not a medium material, energy transfer from one position to another. Now this is known as a, these waves are known as a progressive waves. Okay, student, now clear what is the wave? When we disturb the medium, there is a disturbance produced in medium, and this disturbance travel. Now this, when this disturbance travel forming the wave, now there are two types of the waves. Number one, the progressive wave. Number two, the stationary wave. Progressive wave is a moving wave, moving from one position to another position. In this situation, only the waves moving, particles are not moving, energy moving, particles not moving, and but moving from one position to another. This is a progressive. In a stationary wave, there is no movement. Waves are not moving, waves are stopped. When the progressive waves form, what are the main things? When progressive waves form, medium material disturbs, medium material disturbed, but not moving, mean only vibrating. Particles vibrating, oscillating. Medium particles are not moving. only not leaving their place, only vibrating, only vibrating. The movement is just like a vibration, not leaving their place. But energy transfer from one place to another place. Now, this is called the wave. Yes, student, clear? If all the things are clear, that's good. When anything is not clear, you comment on comment set. No, no, I'm starting the some definition belong to the wave, just like amplitude, waves maximum displacement from equilibrium position, frequency, the number of the complete oscillation. No, these are the definition. These will clear when you know about the diagram of the wave. What is the amplitude in longitudinal wave or in uh, transfer wave? No, there is diagram given. This diagram is of uh, transferring wave. There is not given the diagram of the longitudinal waves. In diagram, we can understand these easily. Frequency, wavelength, speed, phase difference, and period. Now I'm starting the first definition. What is the first? Amplitude. We know that there are two types of waves. Number one, the longitudinal wave. Longitudinal wave. Number two, transfer wave. Now these are the waves type. What happens in longitudinal waves? This wave consisting the rarefaction, mean expanded portion, and compression, mean compressed portion. The particles are there in this portion. Pressure is higher in this portion. These are compressed particles, compression and rarefaction. Now rarefaction also. Now compression. Now these waves consisting of the compression, rarefactions, compression and rarefaction. These are alternatively moving and transfer in progressive waves. First rarefaction is formed, then compression, then rarefaction, then compression. Longitudinal wave consisting compression and rarefaction. Now these compression and rarefaction forms from the main position and moving right and left. When the rarefaction just like moving from the right side towards the maximum length and at the left side at maximum length. Now this length, this distance from the mean to the maximum of the rarefaction, similarly from the mean to the maximum of compression. Now it is known as a amplitude. Any distance on the amplitude is known as a displacement. Okay, just like for example, this is a position O. This is position O, and this is maximum A, and this is maximum B. This is position O, this is maximum A for compression, and this is maximum, for example, C for compression. In both, from mean to A maximum, B maximum, in compression also, mean to C maximum, A maximum. These are the maximum. These are known as the amplitude. Now, these maximum displacement is known as amplitude. Any distance on this line from O to any distance like D, like E, this is displacement. maximum displacement from the mean of compression or rarefaction in longitudinal wave. In longitudinal, this is longitudinal wave. Okay, when there is a transfer waveform like this is the transfer wave. In this transfer wave, the maximum displacement of crest here, the maximum displacement of the trough here. These are the crest and trough. Longitudinal wave consisting the crest and trough. When there is a trough, when there is a crest, now this is the maximum displacement. It is known as a amplitude of transfer wave. Clear, student? Now this is the maximum height of the transfer wave crest. This is the maximum height of transfer wave trough. Now this is known as a amplitude. And there is also amplitude in the longitudinal wave from mid to the mean position to the maximum length of the rarefaction. Similarly, mean position to the maximum length of the compression. So this is known as an amplitude. And any distance on the amplitude is known as a displacement. Any distance is known as a displacement. Now, the second, the frequency. Now, what is the frequency? Numbers of waves which are generating in a time. This is the in 1 second. Numbers of waves which are producing in 1 second. This is the frequency of the wave. For example, now there is a transfer wave form. This is the shape of the transfer wave. There is crest and trough forming. We check. This is the mean position of the wave. Now check how many waves form. For example, this is the time 5 seconds. This is whole time is 5 seconds. You check how many waves produce here. Now, if one crest and one trough is involved, now this is the one wave. In transfer, when there is a one crest and one trough involved, this is the one wave. Again, crest and trough involved, now this is the second wave. Again, crest and trough involved, now this is the third wave. Again, now this is the second, and this is the third, this is the first. Again, crest and trough involved, this is the fourth. Again, crest and trough involved, this is the fifth wave. Okay. And again, crest involved. No, this is the half wave. Only when crest involved, this is the half wave. This sixth wave is half. We can say there are 5.5 waves. In 5.5 waves. How many waves are in this? 5.5 waves. Because 5 waves are complete and one is half. And these 5 waves are producing in 5 seconds. When we divide these 5 waves by 5, we get the frequency of the wave. Number of waves in 1 second is known as a frequency. And how we calculate the frequency? For example, we are checking in any graph or in any shape, there are waves produced and there is time given of these waves. First, we count the waves. Then secondly, we divide the number of waves by the time. Then we get the frequency of the wave. Now, same frequency we can form in transfer and longitudinal wave. Similarly, we can easily calculate the frequency in longitudinal wave. For example, this is compression, this is rarefaction. Now again rarefaction, again compression, again rarefaction. Again compression. Now you check how many waveform. One rarefaction and one compression. It is one wave. One rarefaction and one compression. It is second wave. One rarefaction, one compression is it is a third wave. For example, for these three waves, there is a time of 6 seconds. Now, how we calculate the frequency? 3 wave divided by the 6. Now 0.5 hertz. The unit of the frequency is hertz, or we can say second inverse. Now these are the unit: second inverse, hertz, or cycles per second, maybe cycles per second. Now these are the units of frequency. Now student, clear how we count the waves? And in longitudinal wave, how the one wave form? One when the compression, one rarefaction involved in wave. This is the one wave. One compression to again one rarefaction to compression, again one wave. One rarefaction to compression, again one wave. Now these are the waves, and when we are counting, now these are three waves. Similarly, in transfer wave, one crest, one trough, one wave, one crest, one trough, second wave, one crest, one trough, third wave. Now these are formed, and when we count the wave and divide it by the time, we get the frequency. Just run wrong. What is the wavelength? Wavelength is the distance of one wave. Okay. Wavelength is the distance of one wave, just like it is started from here and ended here. No, this is the one wave, and distance of the one wave is known as a wavelength. It is in meter. And again, one crest and one trough. Again, now this is the second wave, and distance of the second wave is known as the wavelength. Similarly, distance of the third wave is known as a wavelength. If transfer wave consisting the crest and trough, no, there is a one wavelength produced. If longitudinal wave, which is consisting the rarefaction crest, one waveform, no, there is a wavelength. One wave distance is wave, and one wave time is known as a time period. One wave distance is known as a wavelength, and one wave time is known as a time period. On time period graph, this one wavelength time is time period. Okay, one wave is consisting compression rarefaction, and one wave distance is the wavelength, and one wave time is the time period, and the frequency, the number of waves in time in 1 second. Now this is the frequency. Now how we calculate the distance? Speed. We know that the definition of speed is the distance travel in unit time. Okay, distance travel in unit time. For example, one wave produce of transfer wave, one wave produce. Now this is the one wave, one crest, and one trough. When it is present in one wave, this is the one wave. This is one wave. One wave distance is wavelength, and one wave time is time period. We know that the speed is the distance upon time. You check in one wave condition, the distance is wavelength, the speed we denote by V, distance is wavelength, and time in the one for the one wave is time period. It's mean we can say in wave, speed equal to wavelength upon time. Distance is the wavelength, and time of the one wave is time period. Now we can say speed is wavelength upon time, and we can say wavelength multiplied by 1 upon time, and the formula of frequency is 1 upon time period. It's mean at the place of 1 upon time period, we can say frequency. Now the formula comes when we put at the place of 1 upon time frequency. we get the formula now. Speed equal wavelength into frequency. Wavelength, one wave distance, and one wave time is time period, wavelength upon time period. Wavelength, we separate the one upon time period. One upon time period is the frequency. At the one upon time period, we put the frequency. Now, speed equal to wavelength into frequency. Now, this is the formula. And unit of speed is meter per second. Okay, student, this is my first lecture on the wave. Every student of O levels, A level can uh, easily understand the topic because these are the basic some definition related to the wave. And tomorrow class, inshallah, I will start phase. What is the phase and what is the phase difference? Subscribe my channel and get more videos on different topics of OA levels. Or at comment side, you can comment which topic you want to study. With me, I will teach this topic on YouTube. You can ask by comment. Okay, Allah Hafiz.